Hi, welcome to the flipped instructional session for Math 08A for Unit 607, Interpret Linear Functions. Our objectives for today are to write the equation of a linear function and determine the rate of change of the function using a point on the line and slope, and to write an equation of a linear function and determine the rate of change using 2 points on the line. So we've actually done this back in Units 3 and 4, but we're just calling things different words. Initial value. This is the y-intercept, which is b. Rate of change is slope, which is m. Slope, remember, y2 minus y1 all over x2 minus x1. So this is all things we've already talked about, but we're using it in different ways in this unit. As a review, the graph of a linear function passes through the point -1, 2, has a slope of 3. What is the equation in slope-intercept? Remember, slope-intercept, y equals mx plus b. So we know that the slope is 3. We don't know b. b, remember, would have 0 with the number. If you were looking at a table of values, you can see the y-intercept is here because the x is 0. We don't have that here. So what we can do is solve for b. We can plug in this -1, 2. We can do a couple things. We could also use our point slope form. So y minus 2 equals 3x plus 1. So let's just do that. Let's distribute. Remember, we always get rid of the parentheses. Rearrange, move the 2. Y equals 3x plus 5. That's slope-intercept form. Oops, excuse me. Nellie decides to sell monogrammed water bottles that keep drinks cold all day. Her cost for the number of water bottles she will sell is shown in the graph. Which statement states the meaning of the intercept? So the intercept is right here. This right here is at 400, just so you can see it. This is 400 on the y-axis. The y-axis is cost. So she has $400 in cost to go into business. She has $400 initially it costs. That's what that means. Each water bottle costs $400. She buys 400 water bottles to start. Well, the cost is just 400. Then we start coming up. We see 10 water bottles is maybe 425. 40 water bottles is 600. So there's no way each water bottle costs $400. She doesn't buy 400 water bottles to start because the number of water bottles is right here. So the number of water bottles on this axis is 0. So she has $400 in costs initially. That's what that means. When you start on this y-axis, this is where we start. She started at $400. Same problem. She started at $400, but now they want to know her cost increases what by every what. So we have two things to find, which means we're talking about the rate, which is the slope. So we have 2 points, just like we did before. Oops, 600. So we can find the slope. 600 minus 400 all over 40 minus 0. 200 over 40 is, that's making me nervous. I got to put it in my calculator because I'm worried I'm going to say the wrong thing. 5. $5 per bottle. Her cost increases by $5 every bottle. Cost, bottle. Rise, cost, run, bottle. So we have rise over run. You need to have those in there. Rise over run, when we have this money per bottle or meters per second or cost per pound. That is a rate, and the rate is slope. Keegan heads out on a road trip. He tracks his distance from home over time in a graph. So distance from home, he has a title. He has axes labels. So all of this you'll need. Time is generally something that's easy to count. Number of things, time, that's generally on the x-axis. This is the independent variable. Time will happen no matter what. So they're asking his distance increases what every what. So this is something per something. So that's a rate, which is the slope, which we can calculate. So let's pull these numbers. We have, what is that? 10, 700, and 0, 100. So 700 minus 100 all over. 10 minus 0. So 600 over 10. I'm telling you what, my division skills are lacking today. 60. So his distance increases 60 kilometers every hour. Rise kilometers over run hours. Same graph. What statement states the meaning of the intercept? So that's the initial. So that's 100 kilometers at time 0, remember. This is time 0, 100 kilometers at time 0. So is he traveling 100 kilometers per hour? No. Anytime you see the 2 units, that's a rate. That's not what an intercept means. An intercept is not a rate. He will be to his destination in 100 kilometers. That really doesn't make sense in the context of the problem. He starts out 100 kilometers from home. That makes sense. The title, distance from home. He starts at 100 kilometers from home. At 10 hours, he's 700 kilometers from home. So that's how we read these. Be sure to check your Class Connect for a flip follow-up or a help lab if you need extra support. Thanks.